Our next theorem or test that we're going to be doing is called the rational zero test. So the last video we were talking about how we could, factor and find our zeros. It's not always that easy. Okay, there's a lot of polynomials that we just can't factor using our normal tools. So when we can't factor, the rational zero test is really helpful because it gives us all the possible rational zeros, not complex ones, rational numbers. So possible rational zeros, it's the factors of the constant term divided by the factors of the leading coefficient. You did this last year in Algebra 2. You'll remember it in just a second here. This is way easier when the leading coefficient is 1. And when it's not 1, it just explodes the number of possible rational zeros. So we're going to do an example here. So we're going to find the rational zeros. First, we're going to list all the possibilities, and then we're going to plug them in and check. So on this first one, our possible rational zeros, these fantastic abbreviations, we take the constant term, which is 8, and we're going to list out all the factors of that. So it could be 1 and 8, it could be 2 and 4, and that's it. They could be negative 2, right? So it could be positive 1 times positive 8, or it could be negative 1 times negative 8. So all of these are going to be plus or minus. I don't know why that one didn't want to show up over there. And then we divide it by the factors of our leading coefficient. Our leading coefficient is 1, which makes us really happy because the only factors of 1 are 1 and negative 1. So what I have to do is I have to divide each of the numbers on top by each of the numbers in the bottom. The good news is 1, 2, 4, and 8, if you divide all of those by positive 1, you just get 1, 2, 4, and 8. No big deal. If you take all of those and divide them by negative 1, you're just going to get the opposite sign, and we've already accounted for that. So we don't really have to pay attention to this for now because it's a 1. On the back side, the next page of your notes we will. So these are the possible rational zeros. Positive negative 1, positive negative 2, positive negative 4, positive negative 8. So what we're going to do now is we're going to plug them in. We're going to plug in f of 1, we're going to plug in f of negative 1, we're going to plug in f of 2, we're going to plug in f of negative 2, we're going to plug in f of 4, or plug in f of negative 4, and f of 8, and f of negative 8. Okay, so you're going to pick up your calculator, you're going to plug in like mad. I already did this because I didn't want to have you to sit here forever while I punched buttons on my calculator that you couldn't see. So when I plugged in 1, I got 6. When I plugged in negative 1, I got 0. When I plugged in 2, I got 0. Negative 2 gave me negative 8. 4 gave me 0. Negative 4 gave me a negative 144. I plugged in 8 and I got 216. And I plugged in negative 8 at negative 840. So we have found these rational zeros. Negative 1, 2, and 4. Okay, so those are the zeros of this function. And remember, can't see it anymore, but this was degree 3. Which means there's 3 zeros and we have found them all. Now, it doesn't always work that way, but it does sometimes, which is nice. So let's try another one like this. We've got this other function. So our possible rational zeros is we are going to take our constant term and find all the factors. So it could be 1 and 4, it could be 2 and 2, and remember all of those could be plus or minus. And then we're going to divide that by leading coefficient. So plus factors of 1 are plus or minus 1. You need to divide each of the numbers in the numerator by each of the numbers in the denominator, but since it's 1, don't really care. It's not going to change anything for us. So we need to plug in each of these. 1, negative 1, 2, negative 2, 4, negative 4 into our function. So we're going to do f of 1, f of negative 1, f of 2, f of negative 2, f of 4, and f of negative 4. And if you're thinking, yeah, this is a lot of work, I'm going to say, yeah, you're right. There's not really a shortcut to this because these are not nice, pretty functions that you can just factor easily. So it's going to take a little bit more work. So plug these into your calculator. I have already done that work. I plugged in 1 and I got 5. -1 gave me -9. 2 gives me 24. -2 gives me -16. 4 gave me 116. And -4 gave me -60. So you'll notice I did not get 0 for any of these. So this means that this particular function has no rational solution. No rational. Now, we know that it has zeros. It's got 3 of them, okay? They might be irrational numbers or they might be complex numbers. So we know that there are 3 zeros out there, either complex or irrational. And again, we had existence theorems. We don't know how to find them, but we know that there's at least no rational ones, is what we found out from this. All right, so here is where we can make things slightly easier using synthetic division, okay? So I'll show you how this works. So we're still going to find all of our rational zeros, but maybe instead of plugging them all in, we can use synthetic division to make it a little bit easier. So our possible rational zeros, we need the factors of that. So 1 and 125, and 5 and 25, is that right? That's it. Plus or minus, plus or minus, plus or minus, plus or minus. I'm sorry, those are terrible. Can you figure out what I'm saying? Oh my word, I'm making it worse. Okay. We have to divide that by all the factors of 1, which are just plus or minus 1, which we don't have to worry about. Okay. So instead of just plugging them in with my calculator, doing f of 1 and f of -1 and f of 5 and f of -5, I'm just going to use synthetic division to try and plug 1 in. I'm going to try 1 because 1's easy. So I'm going to put 1 in the box. 1, -15, 75, -125. And I'm going to use synthetic division. It's just like plugging it into the calculator. We talked about that last week, that we can use this method instead. So that gives me -14 here, let's say 61, -64, and this is the number I'm looking at. Okay, if that's not a 0, then 1 is not a factor. Okay, so, or 1's not a 0, I'm sorry. So 1 doesn't work. So let's move on to another one. Let's try 5. It's the next one in the list. So I'm going to do synthetic division on that. And remember, this is just instead of plugging it into the calculator, is that we can do this. So 5, -10, -50, 25, 125, and 0. Fantastic. We know that 5 is one of the zeros of this function. Now, the other thing that we can do is rather than plugging in all those other numbers, because that's just obnoxious to keep plugging those into your calculator, we've got a depressed polynomial. That's one of the nice things about using synthetic division. We have x squared minus 10x plus 25. And this is factorable. Okay, so let's not plug in any more numbers just to guess and check and see what's work. Let's just factor it and see what does work. So when we factor this, we get x minus 5 and x minus 5. So our other 2 factors are x minus 5. Remember this one? Also x minus 5. So if we factored this thing, it factors into x minus 5, x minus 5, x minus 5. So that means the only 0 of this function is x equals 5. It just has a multiplicity of 3. I forgot the L. Okay, so we do know that this function, it's a cubic. It's going to have 3 zeros, and we found all 3 of them.